All right, a rate of change problem. So we're going to graph this. In fact, because I don't have a calculator in front of me, actually I do, I'm lying to you, but let's say I didn't, and I still wanted to do this problem. I know that the graph of f of x equals x squared minus 3 is going to look something, I'm going to erase this, but something like that in this area. So it's going to look something like this right here, and I know it's going to cross down at 3. But instead of doing that, I'm going to do a table where I want to know what happens over the interval 1 to 4 on this thing. So let's figure out what the coordinates would be of that. In other words, let's make a table that's xy, or we could say x and f of x. Okay, so our x values we're interested in is 1 and 4. So what would the y values be? Well, we have to do two problems here. We have to do f of 1, which would be 1 squared minus 3, and that would be 1 minus 3, which is negative 2. So we can put negative 2 here. And we also have to do f of 4, which would be 4 squared minus 3. I should put that in parentheses and be good there. So that's 16 minus 6, which is 10. Well, it's not. Let's see here. I need to back up a little bit. We need to back up because this is minus 3 right here. Minus 3. Got a little ahead of myself. So this would be 16 minus 3, which is 13. That must be better. So now let's plot these 2 points on here. So let's do it blue. 1, negative 2 would be right here. 1, negative 2. And 4, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Up about there somewhere. And we know that this has a y-axis intercept of negative 3, so it's going to hit right about in here. So this parabola is going to go like that, something like that right there on each side. But I'm just concerned about it over here from the interval 1 to 4. This coordinate here is 4, 13. And what we're trying to do is find the slope of a secant line that runs right through those 2 points. Like that. And I'm going to have to exaggerate that it actually does hit that. Okay, so it looks pretty good. We need to find the slope of that line. And remember, slope is just y, delta y over delta x, which we can just use pretty much the slope formula on that. I mean, this would be y2 and y1 and x1 and x2. See, now happy Friday to everyone. x1, y1, my goodness, x2, y2. And we can plug that in there because the slope formula is y2 minus y1 over x2 minus x1. Okay? So let's plug it in. And we got 13 minus negative 2 over, 4 minus 1. So that would be, if I squeeze that in there, 15, positive 15 over 3, which would be 5. So the slope of this purple line here should be 5. So it should be up 5 over 1, up 5 over 1, and so on. This would be the rate of change between the interval 1 and 4. Okay, have a good one.